Hello dear children, how are you all? Hope you all are fine and doing well. Dear children, we are doing the chapter 4, that is energy. Don't forget that it is ICSE Physics Class 7th. Okay, so dear children, already 2 classes we have completed. I mean to say 2 videos are uploaded. This is the 3rd video, and one happy thing is that this is going to be the last video. I mean today we are going to complete the energy chapter. My God, I think some of you may feel relaxed. Thank God, sir, we are going to finish the energy chapter. Yes, dear children, it's not me, it's you are going to complete the chapter to do the best in your exams. Okay, fine, dear children. So let us recall once again what we could discuss in the previous 2 classes. So we covered about what is the work done, units of work done, what is the energy, units of energy, the different forms of energy. There we discussed about the potential energy, kinetic energy, and the conversions of potential and kinetic energy. Dear children, let us recall once again. Just it may take a couple of minutes, but we'll get a kind of feel, and it's like we should feel that yes sir, just we are in a continuation. Okay, fine. Children, when you consider some work is done, so whenever force is acting on your body and the body is displaced, then we can say that some work is done. And the SI unit of work is joule, CS unit of work is. And one important point, dear children, whenever work is done on the body energy increases. Whereas whenever body does the work, and its energy decreases. So then what is energy, dear children? The capacity to do the work is called energy. More the energy you have, more work you can do it. Less energy you have, less work you can do it. Dear children, have the enough energy to do the more work so that you can score the more marks. Hey, more the energy, more the work, more the performance in exam, more the marks, more the happiness for you, for me, for your parents too. Okay, fine. And here energy and work both are related terms. That's for same units we used to express even energy also. So the SI unit of energy is joule, CJ unit is erg. And different forms of energy we could cover. What is that here? Mechanical energy. Of course, it is in the form of it is of 2 forms, as a potential energy and a kinetic energy. And then heat energy. Children, especially we use a unit called calorie to measure the heat. And how both are related? 1 calorie is equal to 4.186, but approximately we can say 1 calorie is equal to 4.2 joules, or 1 joule is equal to 0.24 calories. Then we discuss about the light energy, chemical energy, sound energy, magnetic energy, electrical energy, atomic or nuclear energy. And later we could cover in detail about the mechanical energy. There we discussed about, children, what is the mechanical energy? The energy possessed by the body due to its rest or motion is called mechanical energy. And the mechanical energy is of 2 kinds. It is in the form of 2. It is 2 forms, right? One is the potential energy, one is the kinetic energy. Dear children, what is the potential energy? The energy possessed by the body due to its state or a position or a configuration is called potential energy. Example: stretched arrow, stretched rubber, compressed spring, raised hammer, water stored in a dam. These all are the situations where potential energy is stored. Bodies have potential energy, and potential energy depends on 2 factors. Potential energy depends on the mass and height. More the mass, more the potential energy. Less the mass, less the potential energy, provided height remains constant. Same thing with the height also. Potential energy increases with the height, potential energy decreases with the height. Okay, fine. This is about the potential energy. Next, kinetic energy. So children, the energy possessed by a bodies due to their motion is called kinetic energy, which means what? The bodies which are in motion will have a kinetic energy. Simple. Any object is in motion means it must have some energy, that is a kinetic energy. And kinetic energy also depends on 2 factors. One is the mass, another one is speed, dear children. Yes, how can we increase the kinetic energy? By increasing the mass or by increasing the speed. How can we decrease the kinetic energy? By decreasing the mass or by decreasing the speed, we can decrease the kinetic energy. And later we discuss the conversions of potential energy into kinetic energy. One important part I repeat once again, I think in last class also I might have told you this. Potential energy is purely stored energy. Directly we cannot use it. If you want to use the potential energy, it has to be converted into kinetic energy. The best examples, compressed spring when released, potential energy changes to kinetic energy. When a arrow is released from a stretched condition, yes, potential energy changes to kinetic energy. When a water stored in a dam released, potential energy changes to kinetic energy. So these are the topics which we could cover in the previous 2 classes. Those links will be given in the description. Go through those videos to get a full command, so that you have a feel of continuation. Then we'll do the best in today's class also. Yes children, what is today's goal? What is today's agenda? In today's class, we are going to discuss about the law of conservation of energy and the conversions of energy. Very important. Conversions of energy. Under that, we also can see the law of conservation of mechanical energy. There we can take an example of a roller coaster and a freely falling body and an oscillating simple pendulum. Finally, hydroelectricity. So these are the a few topics which are left, dear children, and we are going to cover all these topics, so that with that entire energy chapter will get over. Okay, fine, dear children. So let us start law of conservation of energy. Children, let us take a small example to get a full clarity. For suppose, dear children, so we know that electric bulb, okay, let us think it is electric bulb. Hey, I am not drawing a pot. Some of you may feel that, sir, it's looking like a pot. No, can adjust, my dear children. Okay, so let us say here is some, okay, it is like, yes, bulb. So here is wire, ting, 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 positive, negative. So when we switch on the bulb, ting, 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 light glows. What kind of energy are we giving? Electrical energy. We are giving electrical energy. For suppose, dear children, let us say energy is in joules, right? So let us say 100 joules of energy we gave. Let us say 100 joules of energy in 1 second or 1 minute, you leave it. 100 joules of energy is there. So here we are getting into light. We are getting light. So electrical energy changes to light energy. When I say like this, some of you may get wondered, sir, after some time bulb gets heated up, right? Means some heat energy also involved. You are absolutely right, my dear children. It gets heated up. Means what here? Some heat also produced. Let us say that here. For example, this light energy, let us say some 92 joules. Then this must be 8 joules. And dear children, this is useful, but this is useless, unuseful form it is. Unuseful. Try to understand. So do you think that what is the heat which is produced, which we use to cook some food? No, it is not that. That much heat is not produced. It's not used. But here what I mean to say that here, try to understand. How much energy are we giving? 100 joules of energy is giving. This is input energy. Output energy, light plus heat. Light is how much? 92. Heat is how much? 8. So it is also 100 joules of energy only. Means what is happening here? Here 100 joules only, here 100 joules only. Means are we producing any extra energy? No. At the same time, are we destroying energy? No. Energy remains constant. Energy remains constant. Try to understand. Energy remains constant. Okay, fine. Let us take one more example also. Let us take some motor. Electric motor, let us take the children. Let us take a water motor will be there, water motor. Okay, let us say water motor. So let us say we are giving some 500 joules of energy. In which form? Electrical energy form only we are giving. Okay, then motor starts running. Running means it won't run from one place to other place. Not that running, it works to bring the water from a depth. Okay, means what here? That it is doing some work means what? It has a mechanical energy. Mechanical energy. But at the same time, if you can see, when the motor is working, some kind of sound you can hear, right? Yes, some sound is produced. Okay. Some sound is produced. Okay. At the same time, if you can use a motor continuously, it gets heated up. Some heat is produced. Some heat. I'm not saying that a huge heat is produced and a fire will, no, that much won't be there. Okay. So here some heat also involved. Okay. Here, most of the part is this. Let us say that it is, for example, it is some 90 joules. Let us say that. So it might be some like a 7 joules. See, it's approximate random values I'm taking or arbitrary values I can say. And here is a 3 joules. No doubt this is useful, but this is unuseful to us, unuseful to all of us, unuseful. But try to concentrate, oh sorry, it's a 500 we have taken. Okay, let us say we have taken 100 only. 100 only. Again, you may get a one. Sir, it's a 500, but here 100, where that 400 is going? Oh my God. So again, big questions, big confusion. Okay, let us take it's a 500. It's a 100 only. 100 joules we are giving. Okay. Now, if you can see, it is 100 joules is equal to, in the form of electrical energy. And it is 90 joules mechanical energy in the form of, plus 7 joules sound energy, plus 3 joules heat energy. So total is how much? 97. Again, it's 100 only. It's 100 only. So here children, try to understand. Here only energy conversion is happening. Energy conversion is happening. But on whole, energy remains constant. On whole, energy remains constant. Energy is conserved. Energy is conserved. The children, here we are not producing any energy. We are not destroying any energy. What are we doing? We only converting the energy from one form to another form. This is called law of conservation of energy. Means energy neither be produced nor be destroyed. I repeat once. Energy can, I repeat once, energy can be, very, very important, can neither be produced nor be destroyed. It can be transferred from one form to another form. This is called law of conservation of energy. Children, along with me, come on, say that. What does it state? It states that energy can neither be produced nor be created nor be destroyed, but it can be converted from one form to another form. Of course, whenever energy conversion is taking place, some useful energy will go into unuseful form also. Unuseful. This only we can call it as a dissipation of energy. Dissipation, energy dissipation. Dissipation of energy. Dissipation of energy means what actually? Waste, energy waste is happening. Are you not understanding? Come on, think about your classroom. Teachers will come with some certain energy, they'll start and they'll be teaching you. Do you think that 100% whatever they are teaching, are you taking? Are you in the sense all students? I know, all won't, right? Few people may not understand, few people may not listen, confusions, they won't listen, some disturbance, talking to friends, fighting, doing many things. Okay, means what? Don't think that their teacher's energy is getting wasted. That only energy dissipation. Please don't do that, children. Respect the teachers. It's very important. Really, remember one important thing. Today, it's become very tough task to get the good teachers. So good teachers, I am saying in the future, teacher only won't be there. Because if 100 students are there, just ask them who want to become a teacher. Nobody wants to become a teacher. And here funny thing is that parents wants, not only parents, our society wants the best education system, best education, best teachers. But nobody wants to become a teacher. I don't know how it's possible. We want the best teachers to teach. We want the best education. Yes, it's right, it's good. But who wants to become a teacher? Everybody wants to become a doctor, police, lawyer, political leaders if possible, time permits, engineers, all. Right? Few people wants to become a teacher. I don't know what is going to happen in the future. Okay, let us see. Hope for the best. So this is what actually law of conservation of energy. So energy can neither be produced nor be destroyed. It only can be transferred from one form to another form. But whenever energy conversion is taking place, please try to understand some energy will go into unuseful form also. That only we can call it as a dissipation of energy. Generally we will neglect that. Please try to understand. Generally we will neglect that. Okay, fine. Now let us see some energy conversions. So which are very important for examination point of view. Which are important for examination point of view. One by one we'll see. So electric motor, dear children. So in electric motor what happens? Electrical energy. Children, I am writing E means electrical energy. I become a bit lazy, right? But you don't be lazy. Electrical energy converted into mechanical energy. Mechanical energy. Second one is a dynamo, which is reverse, like a generator. Okay, dynamo. In dynamo, what happens here? Mechanical energy gets converted into electrical energy. Third one, speaker. Children, speaker. In a speaker, so electrical energy gets converted into sound energy. Okay, whereas microphone, in microphone, sound sound energy gets converted into electrical energy. Few examples I'm telling you, few examples. Okay, and the fifth one, let us say photosynthesis. In a photosynthesis, dear children, sunlight, that is a light energy changes into chemical energy. And here let us take a glowing candle. When a candle is burning, I mean to say glowing candle. Okay, glowing candle. Here candle is wax, is a chemical, right? So it is a chemical energy to light energy. Hey, you may get one doubt, sir, why can't we heat? See, try to understand what is the main intention to light that candle, for heat purpose, light purpose. Of course, as I told you, some heat is produced, dissipated energy, that's it. Some that will go in a useless form, that's it. Okay, fine. And let us take a solar cell. In a solar cell, sunlight, light energy converted into electrical energy. Whereas when what we can say, torchlight is on mode. Torchlight is in on mode, I am telling, on mode. So electrical energy gets converted into light energy. Next, burning coal. When we are burning the coal, so coal is nothing but chemical only. So chemical, main purpose to generate heat. It's a heat. Okay, yes. Next, steam engine. So main purpose only we are talking, main energy. In between, some other energies also might be involved, but final input and output on we'll see. Steam engine, heat to mechanical energy. Children, many energies are there like this. These are few examples. If possible, I'll try to show a few more examples on screen. Just note down. So this is all about the conservation of energy, means law of conservation of energy. Hope it is clear. Done. Can I erase 3, 2, 1? Yes. Now, dear children, as we have seen in today's goal, that now we are going to discuss about the law of conservation of mechanical energy. So what is that here? We are going to discuss about law of conservation of mechanical energy. Children, yes, this symbol can be used, mechanical energy. Dear children, what is mechanical energy? The energy possessed by the body due to its rest or motion is called mechanical energy. And we also have discussed that mechanical energy is of two forms. See, mechanical energy means directly we can't see as a mechanical energy. Mechanical energy either in the form of potential or in the form of kinetic, sometimes together. So it's very, very important. So mechanical energy is always equal to the sum of potential energy plus kinetic energy. I mean to say, the sum of potential and kinetic energy is always constant. I mean to say, mechanical energy is always remains constant. But condition, children, this is a very important to be understood. Under one condition only it is possible, this statement is possible. What is the condition? Air resistance is neglected. Air friction or air resistance is neglected. When we can neglect the air resistance, then only the sum total of the potential energy and the kinetic energy is always remains constant. This only we can call it as a law of conservation of mechanical energy. So mechanical energy is equal to the sum total of potential and kinetic energy, which always remains constant provided air resistance is neglected. air resistance neglected. So then how can we understand this? Yes, we can understand by using a roller coaster, we can understand with the help of a simple pendulum. We also can understand this concept by using a freely falling body. Okay, let us take a simple examples so that you should understand this. Okay, okay, first example. So let us take that one, it's like a hill station type thing is there, and ups and downs a kind of road will be there. Okay, and on that road, let us imagine a car driving. Hey, it's too dangerous for all of us. Just imagine a situation. What happened? What happened? It will go right like this. Okay, now look at here. For suppose, so we are taking a case where it is something like this. Okay, okay, like this. Okay, let me just let us try to understand in a detailed manner. Like this, something like this. Let us say that some kind of road, something we are taking. Okay, fine. Now somehow you don't ask me on all these things, or how, why, and all these things. So just think that here one body or one car is placed. Car is placed means somebody should place it, right? Okay, that's what I said. You don't ask many questions. How comes her, who plays, and all these things. Okay. Now let us say that here it is at rest position. Rest position. And from the ground it is at a maximum height. Maximum height. Now children, now this body is at rest. Yes, here they may ask you one question like this. Even though body is at rest, do you think that that body will have some energy? Then many students will get out. Body is at rest? No energy, they'll think. No. But the body is placed at a certain height. Due to the height, what kind of energy body has? Potential energy. So even though body is at rest, yes, it will have energy. What kind of energy does it have? Potential energy. You are right. It is what? Potential energy. Now what I mean to say that, let us say it is point P. Some points let us take, dear children. Here is point B. Here is point C. Here is point D. Let us see that. So whenever we can say it's the energy we can take is 100%. What means no? Let us say, see, you can take 200, 300 also, but in general we will take total energy means like 100 we can take, right? Okay. Now what I mean to say that at a point A, children, please let me give you clarity. At a point A, body rest. Please try to understand. Body rest means velocity is 0. That is speed is 0. Speed is 0 means kinetic energy is 0. Hope you are able to follow my point. At this position, okay now. So it is at rest means what? Speed is 0. So kinetic energy is 0. But it is placed at a maximum height, right? Maximum height. Maximum height means whatever the body has energy, it is only in the form of potential only. At a point A, kinetic energy is not at all taking any contribution. Only potential energy. At a point A, as a body at rest, its kinetic energy is 0. So here it has only means as height is maximum, so potential energy is maximum. So that is maximum is 100%. 100. Now at a point A, what is the mechanical energy? Mechanical energy means you should add kinetic and potential. So 0 plus 100. So it will be 100. Means at a point A, car has a mechanical energy in the form of purely potential energy. Now let us say that this car has started slowly. Of course, it will come zzz, very fast it will go. But let us think, let us take a situation where it's a very slow motion. Now children, as it is coming in this direction, as it is coming downward direction, you tell me, very important, what happens? Height will be decreasing? Yes. At the same time, speed will be increasing. So what I mean to say that as height is decreasing, potential energy decreases. As speed is increasing, kinetic energy increases simultaneously. But the total of potential kinetic energy must remain constant. Let us see. For suppose the car has reached the car has reached this point. Ting, ting, ting. Okay, now this kind of driving is possible or not, don't think all these things. Now dear children, so here at a point B, if you can see, at a point B, so the height is this much. Let us say this is a height HA. Now let us say this is a height HB. Yes, height decrease, right? Height decrease. As the height decrease, potential energy must decrease. Let us say at a point B, the potential energy is, let us say, some 75 joules. And at a point B, don't you think that car has some velocity, car has some speed? Yes, car has speed. Car has speed. So definitely it must have some kinetic energy also. So here kinetic energies should be 25 joules. And the total mechanical energy, if you can see, 75 plus 25, it should be 100 joule only. The sum total is always constant. Now after some time, let us say that yes, car has reached here, car has reached here, car has reached here. Now here, yes, it is at a height HC, it become more or less. But now you tell me at point A, B, C, only at B, as it's coming A to C, don't that C velocity will be more than at point B? Obviously yes. So here height is less, means compared with the point B, as height is less. So hence compared with the point B, here the potential energy of the car must be less. So here at a point C, the potential energy might be, let us say, some 37 joules. And compared with the point B, here car has more velocity. So compared with at a point B, here at this point kinetic energy must be more. So let us say kinetic energy is some 53 joules. But the sum total, that is the mechanical energy, you must add. Mechanical energy is equal to sum of the potential kinetic. 37 plus, sorry, it should be 63. Sorry, extremely sorry. So it is a 100 joules. But now let us say car is going here. But if you can see the children, at a point D, it will go with a maximum velocity, highest velocity. But here height is 0. Height is 0. So at a point D, as height is 0, potential energy is 0. So now it has energy. It must be only in the form of kinetic energy only. So kinetic energy only must be 100 joules. And you can add potential kinetic energy. The mechanical energy is equal to 100 joules. That's it. So children, means at any point the sum total of the potential and kinetic energy must remains constant, provided there is no friction at all. So not only air resistance or see, air resistance means for freely falling body, extremely sorry, and in this case friction is neglected. Air resistance, in the case of fluids we can say resistance, but in the case of when solid is moving over the another solid, we can say friction. When friction, so air resistance or friction is neglected, when this condition is fulfilled, then only the sum total of the potential and kinetic energy remains constant. Children, now in a very short way, let me tell you, children, at this point it has height, maximum height. Due to the height, body will get a potential energy. But at this point, it is at rest. Velocity is 0. So kinetic energy is 0. So at a point A, it has only potential energy. Only potential energy. But at a point D, it has only kinetic energy. Means what happened? Potential energy is converting into kinetic energy. But in between, it may have kinetic and potential energy. But at any point, if you can calculate potential and kinetic energy and just you can add both, the sum of the potential and kinetic energy remains constant. This is what actually law of conservation of mechanical energy. Law of conservation of mechanical energy. Just copy this so that we will move to next example. Hope it's clear. Copied. Okay, 3, 2, 1. Okay, fine. So children, same concept can be discussed with the help of what? With the help of freely falling body. Second one, freely falling body. Freely falling body, falling I wanna follow you. Hey, follow. Freely falling body. Freely falling body means what actually? Look at here. A body is held like this and it is left, it is falling under the gravity. This is what actually we are going to take the case. Okay. Children, let us take here a situation where here is a body. It is held and about when it is left, it is about to fall like this. Ting 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 ting. Okay. Let us say ground. Let us take 3 points. Let us say the point A. Okay. In between point B. Okay. And here it is about to hit the ground. Not touching, just about to hit the ground. Let us say 3 points we have taken. And let us say this it is at a height h initially. Okay, fine, that's great. Height not n, it is height h. And this is a midpoint, midpoint exactly. Let us use the h by 2. Now children, at a point A, okay na, it is held, body is held, means its velocity is 0. So its velocity is 0 or speed is 0. So kinetic energy is 0, that's it. But whereas it is at a maximum height, it is placed at a maximum height, right? To place this body at a height h, so work is done against the gravity that is stored in it as a potential energy. Means at a point A, body has a mechanical energy only in the form of potential. So means what here? Let us say its potential energy is 100 joules. That's it. And the total mechanical energy again, ting 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 ting, 100 joules, should be 100 joules. And at a point B, if you consider, okay now, yes, here V is 0, but here it has some velocity. Try to understand. Children, when a body is at a height h, its potential energy is 100 joules. But when it is placed exactly half of its height, potential energy also half of its value. Means what? At a point B, potential energy will be 100 by 2, that is 50 joule. The remaining 50 joule, yes, it must be kinetic energy. Again, the total mechanical energy will be here 100 joules. Means exactly at point B, half kinetic energy, half potential energy. If you can add both, it will be 100% mechanical energy. Now if you can see at a point C, children, at a point C, yes, almost height is 0. So there is no potential energy at all. So here V is a maximum and it is falling. It hit with a more velocity. So here kinetic energy is maximum, means whatever the energy body has, only in the form of kinetic energy. Now here mechanical energy will be 100 plus 0, it is 100 joule only, that's it. See, you make it a one doubt, sir, let us take a point here. Okay, you can take at this point, if you can take here, yes, here it should have more potential energy, right, because more height compared to this B. Let us say 70 joules of potential energy, some 30 joules of kinetic energy. Of course, if you can take here point D, this is here point E. If you can take point E, so here potential energy might be some 21 joules and the kinetic energy might be 79 joule. So children, here what is happening here? Potential energy is converting kinetic energy. You make it one doubt. Sir, what if I throw body vertical upwards? Initially it has maximum kinetic energy, and as it is going upward direction, its velocity is decreasing, so kinetic energy is decreasing, but simultaneously height is increasing, hence potential energy is increasing. Children, either potential energy may convert into kinetic energy or kinetic energy may convert into potential energy, or in between body may have both, but at any point the total mechanical energy remains constant, provided in this case air resistance is neglected, previous case friction is neglected. Okay, it is a case 2 to understand the concept of law of conservation of energy. Hope it's copied. 3, 2, 1. Okay, fine. Now let us take the oscillating simple pendulum. So third example is simple pendulum. Simple pendulum. Children, so we know that what is simple pendulum? Here is a rigid support. From this rigid support, by means of a massless string, a bob, a heavy point mass is suspended. Let us say OA is a mean position. The children, now for example, it is taken aside. and it is left. Why? To make it to oscillation, either it has to be taken left side or right side. Then what happens? It will be doing oscillation. Simply it will be, it's like a mean position. Now it will be oscillating. It will be oscillating. Okay, so here is, let us say here, it has reached extreme ends, let us say that, extreme ends, and here also another extreme end. Okay, let us say it is a B, it is C. So it is almost ground, almost ground it is ground. So if you can see, at extreme ends, body has reached maximum height, body has maximum height h. But at a mean position, body has maximum velocity. Children, just think once, as it is going from A to C, it is going against the gravity, right? So whenever it is going A to C, try to understand, its velocity is decreasing, but height is increasing, right? Try to understand. Same thing happens when it is going from A to B also. But whereas if it is coming from B to A, height is decreasing, but velocity will be increasing. See, as it is going from A to C, it's a mean position. It crosses this mean position very fast. But as it is going towards C, slowly. So after reaching this extreme ends, velocity will be 0. Children, at this extreme ends, velocity will be 0. So kinetic energy will be 0. Here also, kinetic energy will be 0. So at extreme ends, whatever the bob of the pendulum has energy, only in the form of potential energy. 100% in the form of potential energy. Here also 100% in the form of potential energy only. 100 joules or 100%. But whereas at a mean position, here height is 0. So potential energy is 0. Only here body has in the form of kinetic energy only. At extreme ends, kinetic energy is 0, but potential energy is maximum. But a mean position, as a height is 0 almost, potential is 0, and it is crossing with a more velocity. You can try with your hand also, children. You can try like this, you can try here. So as it is going extreme ends, you can see your hand is becoming slowing down, but when it is going this point, very fast it is going like this. Try to understand. Okay, but you may get one doubt. See, in between B and A, in between A and C, yes, in between B and A and C, body has certain height, body has certain velocity. So hence, body has both potential energy and kinetic energy. And don't forget that you can add at any point you can add potential and kinetic energy. It must remains constant. That is what actually law of conservation of mechanical energy is telling, provided there is no air friction or there is no air resistance or friction. So this is all about actually law of conservation of mechanical energy. Law of conservation of mechanical energy. Copied. Yes. So the children, one important point I am going to tell, with that you will feel very happy. Can I tell? Can I make you all happy? Yes. Last topic which we are going to discuss. So that is hydroelectricity. Electricity. The children, usually if you can see a water in a reverse, it is in motion. And already I told you that anything if it is in motion means it should have some energy. So the water in motion, let me tell you, I repeat, the water in motion has some energy. That energy only we can call it as a hydro energy. Now let us say here is, now the water which is in motion, try to understand, the water is coming. So the water in motion, now it is stored in a dams. We know very well that. So see, the water in motion has energy. That energy we can call hydro energy. Now that we are storing, that water we are storing, means can we destroy this energy? No. That energy is converted. The water stored in a dam has what? Potential energy. Now let us say that here, yes, here completely This is placed in a dam, let us say that. So let me try to explain like this. Okay, how should I? Okay, so let us say something like a dam. Okay, so it's completely water stored, let us say that here. So here is a wall of the dam. Ting 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 ting. You know, children, at the bottom the walls of the dam made thicker. You know why is what is the reason? I repeat once. At the bottom of the dam, walls are made very thicker. What is the reason? We'll discuss later. Okay, fine children. Now this, okay, now water is stored. Let us say water is stored. Let us say completely now water is stored. This stored water has purely potential energy. Now when this water is released, so this water, now water will be flowing. So let us say that here water is in motion now. Water is in motion means what here? Potential energy is converting into what energy children? Kinetic energy. Try to understand. So potential energy is converting into kinetic energy. Mean the water which is in motion has ability to do the work. If anything is there across in between, the water will take along with that. My God, you know very well that water in the form of tsunami can take big buildings, everything only, right? Means it has ability to move the things. So the water which is in motion has ability to move the things. Yes, this point is very important to all of us. Means what? So across this water, as the water is in motion, for suppose here a kind of turbine is placed. A turbine, children, let us say turbine. Okay, let us say some turbines are placed. Ching, ching, ching. Let us say turbine. Hey, in exam they don't ask you to draw the diagram, don't worry about it. Okay, turbine. Now what happens? The water which is in motion will make these turbines to rotate. Yes, turbines will be rotated. And for these turbines, let us say here one shaft or one rod type thing is attached. So obviously this shaft also rotated. At the end of this shaft, you know, one copper coil will be there, a rectangular copper coil will be there. Ting 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 ting. And these, see, as a turbine is rotating, shaft will rotate. If shaft will rotate, this copper coil also rotate. So copper coil will be rotating. But where? Yes, we will make an arrangement so that here is a south pole and here is a north pole. Which means what? Here? This copper coil is placed in a magnetic field. The children, of course, this you will be learning class 10th. We are not going in depth. Whenever copper coil is rotated in the presence of magnetic field, electrical energy is produced. That we will learn. See how and all this function. See, our interest is not that. Our interest is in a hydroelectricity, how the energy conversion is taking place. Why and what is the principle, we are not going to discuss now. That you will be learning in a class in the electromagnetism chapter. So finally, which energy is coming? Electrical energy is produced. Electrical energy is produced. That's it. So this is what actually. So examination point of view, they don't ask you to draw the diagram. Of course, they may give you diagram, they may ask you to identify the energy conversions. So in a simple here is potential energy to kinetic energy to electrical energy. That's it. So the children, I am so happy to say that we have successfully completed the chapter 4, that is energy. Okay, dear children. So I think as we have done the chapter 4, next I think we can start a chapter, 5th chapter, that is light. Of course, it's quite interesting and it's very much important in your higher class also. So dear children, so with this we completely done. And as I told you that previous 2 classes links will be given in the description. Go through that video. And if you like the video, just suggest to your friends, just like the video, share with your friends and ask them to subscribe. And thanks for all the support. Okay, thank you so much. All the very best.